Hi, we continue section 5D, a linear approximation of earned interest. And now we have a general case. So consider the following cash flow and approximate effective interest rate I by simple interest. Okay, so we have the $8, we have to pay $8 at time 0 and C $1 at time Ti and C2 at time T2 and Cn at time Tk. And finally, that we get the paid back the B dollars. So we want to calculate I. And okay, so the interest rate is pretty complicated because these T1 to Tn are fractional. So we approximate this by simple interest. So simple interest is proportional to the time period. So it's not too complicated even if TIs are fractional. Okay, so the simple interest rate, so we can think about this similarly to the previous example. So $8 at time 0, this earns the 1 year of interest by t is equal to 1. And the C sub I is a little confusing. C sub K, this earns basically 1 minus Tk years. So for example, so this one, the Tn to 1. So this is the 1 minus Tn year. So that means in general, the Ck earns 1 minus Tk years of interest by t is equal to 1. So that means that we have the A, it earns. So this, we compare the accumulated value of the both sides of this time diagram. So on the upper side, the A earns 1 year of interest. So A times 1 plus I, and take summation K is equal to 1 to N. Ck times 1 minus Tk I. Okay, so the Ck is I. Then finally, that we get back the principal. So that means the 1 plus 1 minus Tk times I. So this is equal to B. So if you simplify this, then I becomes the, okay, so the B minus A constant term is B minus A minus the summation of Ck. So that is B minus A minus the summation of Ck. Then the denominator is the A. So you can see here A times I, so the denominator is I, and the coefficient of I is the Ck times 1 minus K. So that means the summation of the Ck times 1 minus Tk, so summation over K. So this is the general case. Okay, so the why simple interest rate is justified to approximate the annual effective rate. And actually, if we think about the annual effective rate, the simple interest rate is the first order Taylor approximation of the effective interest. So, okay, so we consider the just specific the payment. So the Ck dollar at time Tk. Okay, so what's the accumulated value at time 1? So it accumulates interest for 1 minus Tk years. So that means that this Ck becomes the Ck times the 1 plus I, the to the power, the 1 minus Tk. So this is the exact interest that these Ck dollars earn. And but the simple interest approximation. Okay, so I would say that the Taylor expansion, first order Taylor approximation of this Taylor approximation of this one is equal to, actually, if you differentiate it several times, that you can get the first order approximation is the 1 plus actually the 1 minus tk times I plus higher order of I. So that means that this one is approximated by 1 plus 1 minus tk. And this is actually, this equals the simple interest. So using simple interest is equivalent to using the first order Taylor approximation of this one. So that's why that we can get reasonably good estimate by simple, the approximation by simple interest rate.